Welcome to this presentation on group anagram problem. Today we will walk through a solution in C++ to efficiently group anagrams from a given array of strings. Let's dive into the problem. The objective of the problem is to group all anagrams from a given array of strings. An anagram is a word formed by rearranging the letters of another word. For example, at, cat, and tet are all anagrams. We are given an input array of strings and our task is to return a list of groups containing anagrams. Let's look at an example. To solve this problem, we use a hash map to efficiently group the anagrams. We will take the following approach. First, we sort each string in the array. Then we use the sorted string as a key in the hash map. The values of the map will be the list of anagrams. Finally, we collect the values from the map into our result and return them. Here we begin by initializing an unordered map to store the grouped anagrams. For each string in the array, we sort it and use the sorted string as a key in the map. This ensures that all anagrams will have the same key. Next, we continue by appending each original string to the list of anagrams corresponding to the sorted key in the map. After processing all strings, we extract the groups of anagrams by collecting the values from the map. These values represent the final groups of anagrams that we return. Let's now look at the C++ code implementation for this approach. We start by including the necessary header files. The function group anagrams takes a vector of strings as input. We create an unordered map to store the sorted string as a key with each list of anagrams as the value. In the next part of the function, we iterate through each string in the input array. For each string, we sort it and use the sorted string as a key in the map. We then push the original string into the map under the corresponding key. Finally, we collect the values from the map, which are the grouped anagrams, and return them. Now let's analyze the time complexity of our solution. Sorting each string takes big O of n times m log m time, where m is the length of the string. Since we do this for each of the n strings in the array, the time complexity is big O of n times m log m. In terms of space complexity, we use an unordered map to store the anagrams and a result vector to store the final groups. Both of these require big O of n times m space, where n is the number of strings and m is the length of the longest string. Let's go through an example to understand the algorithm better. Suppose our input array is act, god, cat, dog, tet. In the first iteration, we take act and sort it, which gives act. We use act as the key in the map, and the map now looks like act, act. Next, we process the string god. Sorting it gives dgo, so we add god under the key dgo. The map now looks like this. We continue this process for the remaining strings, and in the end the map looks like this. Our final output is given below. Key takeaways from this approach. Sorting is essential for grouping anagrams efficiently. Hash maps provide a fast way to store and retrieve anagram groups. Understanding the trade-offs in time and space complexity is crucial. And finally, practicing similar problems will help enhance our problem-solving skills. To conclude, we have successfully sorted the group anagrams problem by using sorting and hash maps. We can explore other variations of string grouping problems, and as we work with different constraints, optimizing our solution will be an important next step.